So let's now learn about some terminology. And these terms, actually, you might find them familiar because they really borrow from what you experience in the real lives. So we're going to talk about clients, supplier, and also a contract that bind them together. First of all, we got a supplier who implements or provides a service. Let's say microwave. So we have a microwave manufacturer being the supplier. And clients actually uses a service provided by some supplier. And for example, maybe I purchase some microwave. I will be the clients of the microwave manufacturer. Okay? And now, if you think about programming, so what does it really mean for a particular item to be a client? What does it really mean for a particular item to be a supplier? So what kind of service can we provide in the programming context? So before I get to concrete example in the next slide, maybe you can pause a little bit to think to yourself, what can be the clients and what can be the supplier. I'll give you a little bit hints. Caller versus callee that you learned in 2030. Okay, let's move on with this microwave example. So the clients in this case is required to follow instructions if they want to use a microwave. They want to make sure the power is actually on, and also they close the door when they heat something, and also whatever they want to heat is actually not explosive, right? So this is the assumption that the supplier or the microwave manufacturer can assume is really that the clients follow the instruction, right? That's one way. So before the clients can assume, before the clients can expect anything to actually work from the microwave, the clients must actually satisfy certain obligation. They have to follow the instruction. Okay, and then symmetrically, let's say the clients, like myself, I follow everything that's actually outlined in the manual for the microwave I purchased. So now if I I put my lunchbox into the microwave, what can I expect from the microwave manufacturer? Of course, my lunchbox should be properly heated. So you can see it's really like a bidirectional expectation. The supplier, microwave manufacturer expects something on the user. Symmetrically, the user also expects something from the manufacturer. And of course, the thing they actually expect somehow is related to each other. So that's something I'm going to draw a matrix to show you the relationship. And one thing to note, the clients typically does not have to care about how the supplier implements that. For example, if I'm the user of the microwave, do I need to know how to assemble or how to engineer or to optimize a good microwave myself? Of course, I don't have to. Myself being able to drive a car doesn't really mean I need to know the mechanics for the car, right? Hopefully that also makes sense to you. And this one tells you, let me give you one analogy in your programming OOP. If you go to your Java API and you find that you actually there's so many library classes there for you to use. For example, hash map or tree map is one of our two of the example classes. When you actually use those any methods from those library classes, you are the clients. And as a client of those library classes or their methods, do you have to know how those methods are implemented? No, you don't have to, because for the clients, all you do is to use some service, in this case, the methods provided by some other developers, so they are the suppliers. And for me as a client, I don't have to worry about how they are implemented. Somehow I assume they are working correctly. And me being the client, I can also be the supplier in other contexts. For example, if I contribute some library classes to the Java API repository, so I will be the supplier, and anyone who actually uses my library class, they will be my clients, right? So I will be the supplier in this case. So anyone can be the client and supplier simultaneously in different contexts. So I'm not really writing this down, but hopefully that makes sense to you. You can feel free to take notes if you wish. Everything up to now, I'm just trying to talk about what really makes sense in real life, and also how you can transfer that concept or adapt it to your programming context for OOP. So now we talk about benefits and obligations between the two parties, supplier and also the clients, right? So now let me draw this matrix over here. Let's just talk about the general case over here, and then I will talk about the microwave case. So we have benefits and obligations being the columns, one dimension here. And now imagine that for the rows, it's going to be clients and supplier. Okay, I'm going to tell you the answer right away, but you can think about how you might fill in the matrix. For example, let's say this. If I put, let's say, clients over here, okay, if I put clients here, what should be the benefits for the clients and what should be the obligation for the clients, right? And also for the second row, if I put supplier over here in the second row, what should be the benefits for the supplier and what should be the obligation for the supplier? Okay, let me show you the answer. You may think about it, pause the video, think about what you may want to do before you actually resume the video. So for the clients, the benefits will be to obtain a service. Okay, given that they satisfy the obligation of following the instructions for whatever service they're using. For example, microwave, right? And also for the suppliers, now think about what would be the benefits for the supplier. Well, in some way, supplier, do they really have to, for example, create any microwave that will always work unconditionally? Not necessarily, right? Because it has to be some reasonable working condition for the microwave to heat up the things. So now the benefits would be exactly what the obligations are for the clients. So now notice that the supplier, because they can assume the instructions are followed by the clients, so they don't really have to spend so much energy worrying about heating up, for example, heating up some explosive properly, right? And also, the obligation for the supplier will be exactly what the benefits are for the clients. So now you can see they're kind of symmetric to each other. So now I would like to just draw one more matrix for you, just for to help you understand. Okay, so now let's think about basically client, supplier, and also obligation versus benefits. Okay, so I will draw that over here. So we have clients and we also have supplier. And we have benefits and we have obligations. Okay, I'll put the general concept again just to review, because this matrix is really important. So you can think about this matrix is really some guidance later on for you to actually use design by contract to facilitate your developments. So let's do that carefully. The client's benefits would be they can actually obtain the service. And then their obligation, I'll use another color, would be to follow instructions. And then, as I said before, the obligation for the clients is exactly the benefits of the supplier. So now, so that means instructions are followed. So that means the supplier doesn't have to worry about any case where the instructions are not followed. They can assume it's always followed. And similarly, you can think about what the benefits are for the clients are exactly the obligation for the supplier. Because if the clients actually follow the instruction, they fulfill the obligation, supplier will be responsible then to actually provide the service, right? So now they will provide the service. Okay, I'm just giving a little bit more information than what's shown in the slides. Hopefully that will actually help you understand a little bit more thoroughly. So now that's basically what we saw in the previous slide in the matrix over here. So now let's think about how we can use a microwave example, right? So we talk about a microwave example over here. So now the clients will be whoever who purchased the microwave, right? So let's say microwave user, right? This particular example. And then what about a supplier? Well, of course, they will be the microwave manufacturer. So now what will be the benefits for the user? Well, apparently, assuming that they actually follow the instruction to make sure they close the door, lock the microwave, and give something that can be heated, so that would be their, and then they can heat up whatever they want. Let's say they can heat their lunchbox. Okay, so this is one particular example, right? And now, of course, at the same time, that should be the obligation for the manufacturer. They have to make sure if the instructions are followed, they can heat up whatever that's illegitimate, right? So that means the lunchbox should be heated. Okay, I'm choosing another color here. And then what about obligation here? So now the obligation for the clients would be they have to actually follow the instruction. So have to make sure the power should be on. Okay, I'm going to write it a little bit more briefly, but we'll see the more precise encoding later. The power must be on, and also the microwave must be locked, and also it should be something that's non-explosive, right? Non-explosive. And now this obligations over here is exactly what the benefits are for the supplier. So that means supplier don't have to worry about the following scenario. If the client simply open the door of the microwave and also don't lock it, and also they put something that will explode, the supplier doesn't have to worry about this case to heat it up, right? So now the benefits really is for the supplier is they only have to worry about the case where the power is on, the door is locked, and also they're heating something that's non-explosive. Okay, it's not difficult. I'm just trying to give you the general guidance and also give you one example. So really make sure you understand the mutual benefits and also mutual obligations between the client and the supplier. And so there's a contract between the two parties. A contract will be violated from either end. It could be violated by the clients or it could be violated by the supplier. For example, let's say if the instructions are not followed, who will breach the contracts? Apparently, it will be the fault for the clients, right? If they didn't follow the instructions, then the supplier will be under no obligation to provide the service. And if the instructions are actually followed by the clients, but the service is not satisfactory. So now satisfactory over here is somehow ambiguous or it's not precise. So now in this course, since we know we have some tool in our toolbox, which is logic that you learn in 1090. So we are going to actually define mathematically what satisfactory really means later in terms of predicates. We'll do that later. Okay, we'll see lots of examples throughout the course. But if somehow the service is not satisfactory, of course, it should be the supplier's fault. Okay, so now really study carefully the matrix and also understand what the benefits are and what the obligations are for clients versus supplier. So now we'll concretize the story that we have been telling about clients versus supplier, especially microwave user versus microwave manufacturer, especially in the context of object-oriented programming. Since we haven't really shown you IFO code, not yet, but let's just show you the familiar syntax for Java. We just talk about implementation for a bit, just to see the contractual relationship more clearly. Okay, let's see some fragment of code. Let's say we have one single class on the left-hand side. We got microwave with two attributes on and locked. On can be either true or false, and also lock can be true or false, right? On being locked being true, that means it's locked, right? It's quite obvious. And then we can have mutator methods over here to turn on the power, or we can actually to lock the microwave. And then we also got a mutator method called heat over here. And then this is just anything. So we just use object. Remember, object is the most general type in Java. So anything may be heated, may be passed as object. Of course, you have to be careful. If the stuff is actually explosive, in that case, you cannot really satisfy the obligation for the clients. So now we just put some comments over here. Of course, you can do it more formally using Javadoc. You can use the tag add precondition or add assume, but let's not worry about it for now. So now we simply assume that in order to heat some stuff, the current value for on, the current microwave objects, its on should be true. Its lock should be true, meaning that it should be turned on and also the door should be locked. And also the stuff, whatever object it is, should not be explosive. Okay, that's conceptually the case. So that's the one class on one side. On the other side, we're going to see microwave user. Okay, microwave user is simply think about whether there should be client or supplier, right? Remember I told you previously, earlier in the lecture, I said, think about caller versus callee. Okay, I'll review that in just a moment. So let's say in the microwave user class, we have a main method, which means we're writing some application about microwave. Let's say we declare m of type microwave and then initialize the microwave objects here. And then we actually assign some object value to obj over here. So here I put question mark simply means I don't know what it is. It can be anything. You might be reading some input from the user, or you may be reading something from the console. I don't know, just anything. Okay, that's why I put question mark. It's unpredictable. It's uncertain. And now let's say I simply turn on the microwave. I call the power, right, to turn it on. Also I call the lock mutator to lock m. Okay, turn it on, lock it on. And then after this, I would say m the heat and then objects. Okay, so this is the code fragment. I would like you to maybe pause a little bit the video and then make sure you understand what's going on before I start to explain some details about how to think about client, supplier, and also contracts over here. Okay, let's just go. I'll go over the slide and I'll switch to iPad just to explain. Okay, first of all, we have a method call over here is m the heat and then obj. You can think about every time in the context of OOP, whenever you have a method call, and a method call goes like this. You have a method to call, and then you have the context objects m, and also you got the argument obj. You may not have arguments in some cases, but you always got the context objects. And every time you have a method call, so that means you have a client-supplier relation. Okay, let me switch to the iPad over here, and then I'll show you. Now let's first of all, let's have a look at this particular line and the heat over here. Okay, this is a method call, right? So now you can see that m over here is a context objects. Let's just review quickly about the basics for OO. So this is called a context objects, and then m is of microwave type. How do I know? Because m was declared exactly over here, right? Okay, and now if you look at a microwave class, now if I go back to this particular class to trace, that one there does have a method over here called a heat. You can see the heat is exactly in this particular class over here, right? So that's why it compiles. And then we also got another, let me use maybe blue here. We got an argument object over here, so this is the arguments. Or you can think about it like an input. And in this case, what's its type? Well, it's declared exactly over here. It's of type objects. Okay, I'm just trying to analyze to you what the method call really consists of. Okay, so now let's talk about clients and supplier. So now in this case, apparently we have, basically, we have two classes over here. We have microwave over here. And also we have microwave user. So now we know intuitively microwave should be the supplier and microwave user should be the clients. We know that intuitively from the previous slide, but now programmatically, how do we judge? So every time when you actually have a method call like this, the context objects indicates you are using or you're calling some methods from other class. In this case, you're calling the method from the microwave class. So that means the microwave in this case is supplying some method for you to call, which is the heat method. So now we will know the microwave in this case is the supplier class. And then you can think about this is more like a supplier method because we are using it. So how do we tell the clients? You can think about the class under which you are making this particular method call. It is the client. You can think about informally because we know that the microwave user is actually using the heat method from the microwave class. So now the microwave user class should be the clients. And you can even think about the main method, because under this particular method we are calling the heat method. You can think about this a client class, and this is the client's method. Okay, hopefully that makes sense to you. Okay, let's go back to the slides and see if there's anything else I should say. Okay, the client should be the resident class of the method call. For example, you can see we are making this method call in the context of this class. So now in this case, microwave user should be the clients. And also supplier should be the type of context object. Context object n, which is of type microwave. And I'm using the heat method over here from the microwave class. So microwave should be the supplier. Okay, that's exactly what I just explained to you on the iPad. And of course, here we only talk about microwave versus microwave user. Now, this particular method call can be applicable to any context in OOP. So the most important message for you to take is later on throughout the course, every time when you see a method call in your OOP in IFO, whenever you see a method call like this, you will know what the client, who the client is and who the supplier is.